Okay. Last presentation, nice. I wish I had that in 2009 when we started the T2 project. Approximately 3,000 houses in one model. So I think that would have been a pleasure. For those who don't know what Gardermoen is, okay. For those of you that don't know what Gardermoen is, we have an expansion in the front of the old airport and in the west side of the old airport. That's approximately 140,000 square meters. And in addition, we have over time also modeled the rest of. There is a pointer. Does it work? Should work. Doesn't work.
It does work, it's just very. All right.
Well, what we have today is approximately 270,000 square meters that we try to. We are, let's say, in the middle of a process where we are receiving all the models from the contractors and the design teams and trying to put them into operation and maintenance. And that's a very interesting area. The master idea that we have in this process is having a master information model server on the top that contains all the FM information, data blades, and all that kind of stuff, and most of the information that we want to maintain. And we have also a server at the left side still, that contains all the models from the contractors and the design team. That's proprietary files like Revit files, Tekla files, ArchiCAD files, AutoCAD files, and so on. And then in the middle of this triangle, we have an open source, not open source, but openBIM server that contains repository for all the ISC files that we have received from all the partitions. And from that server, we have capability to push out models to, for instance, viewers like shown here. Kristian will try to do a live demonstration of that later. As we see here, the problem for us is we have a design team that started in 2009, as I said before, in Revit and mainly Revit and Tekla. And then we have a large set of contractors that use whatever is possibility to make a 3D object, and also some BIM objects. So the challenge is now to try to merge this together and refine the product, make the IFC better, make the original files better, and so on. We have a process that have last for 1.5 years, and we still some months left. Hopefully we will finish early next year. Looking at only the IFC models that we have received from the design team and from the other mainly main contractors, we have a total of 3.3 million objects, and as I said before, 270,000 square meters. So there is a lot of objects to maintain. Luckily, back in 2009, waiting for IFC 4 and such tools, such nice formats, We did establish a system of tagging that is only related to our processes. For instance, here we have which contract, and we have also what we call ID number. That's based on Statsbygg in Norge, in Norway. That's a system code from every object. That is a demand in our project that this kind of information is represented on all objects. And today we see the fruits of that. So that's the key to link this together to the maintained system. Then we have down to products, what we are using. Ole Kristian will show more. The Rufus is this master model of all the keys, holding all numbers and have the capability to establish new numbers and then push them down to all the objects. And we have used Jotnes model server for maintenance of the IOC files. We also use this when designing all the commercial areas in the airport. We have about 70 areas that we mainly pushed out small models, cut the models in small pieces, and then deliver that to the design team to work with. So I'll just let Ole Kristian take the word.
Just when you swap. Yes, thank you, Bjørnar. That leaves me -1 minute. So, guess I'll get to it. Thanks to Bjørnar here, maybe the man to thank for the quality of the models produced there. He's a structural engineer by training, and he has been looking over the shoulder to everybody in the design team, working around with his 16mm rebar here. So deliverables from this project is quite extraordinary when you look on the quality and that comes out. Still, we are entering the process of reverse engineering. Bjørnar started talking about these IDs, these key attributes, which in many ways are the backbone of the facility, but that's from, say, a historical period of time where BIM was not around. This was created back in the 90s, actually originated from a German standard, so the Germans in the room might recognize some of the structures here. But basically it identifies what it is, what it belongs to, and where it is. So it's a human-readable format, basically. Now they also started adding QR codes because everybody has machine-readable capabilities right now. It makes us less dependent of classifications and IDs. The point of these design BIMs is that they are designed for being built. They're not designed for being operated. So from an operational or management maintenance perspective, what you're looking for is where things come from. So you need to identify, say, where the flow starts or where the energy has been converted. And you want to track things back so you can shut off the voltage or shut off the water, shut down the gas or whatever. So you want to trace those objects highlighted in red and different system perspectives. And it can be a combination of that. Open-ended in the top, typical mechanical, where you have supply air, extract air, etc. And then you have the electrical hierarchy structure where things just go from the street and all the way to the electrical fixtures. And you will always want to track back to where you can shut things down. The box in the bottom there, that's everything else. That's the building elements, which are just occurrences of types. So you have a wall type, and you have a occurrence, etc. It doesn't have that same kind of connection and connectivity. Still, the classification in the IDs doesn't reflect this as such. So the Rofus was mentioned by Bjørnar. This is actually a content management tool. So it means that you can synchronize properties, attributes to different object classes or categories, if you wish, in Revit. And you can synchronize and suck up whatever is in the design file, and you can put something back in the design file. It means that when you have 100 plus different BIM authoring files out there, you can actually manage those things one place. So in this case, it's just a panel distribution board in Revit, which has a lot of systems, electrical circuits, which are then synchronized back to the database. Capture data when it's created rather than in retrospective for documentation, which we always do elsewhere. So the BIM structures can be like this, but it can also be much worse than this. So you need kind of to reflect this in your guidelines as well. I'm just mentioning it. That's lessons learned as we go along. So a different view of the same thing. You have all these native formats, BIM authoring design tools, which are synchronized then down to the database, which organizes, classifies, gives an ID. And one of the things that we kind of steal from design is the IFC GUID. But we also have this key, this ID, which is the primary key for everything that happens in facility management at OSL. And they have like 30, 40 different systems using these IDs for different purposes. And they try to maintain it 30, 40 places as well. And that's not a good plan, because data don't match. You will have deviations. So what they decided to set up is one single source of truth for those IDs and just pushing it out. So at OSL now, every 15 minutes, 70,000, oh, that was too fast. 70,000 objects are pushed from that database to the operation and maintenance tool every 15 minutes. And that's out of 300,000 IDs which are in the original database, because that's only the objects which are in operations. You have a lot of historical data there. You have things that you don't operate, so you don't want everything into the maintenance and operation tool. But basically this is what's in the PAS 1192. You have non-graphical data, you have graphical data, and you have the documentation of that. You just bind together by these IDs. And what I thought I would show you is one of the effects that you could have out of that, because you can go from graphical data to non-graphical data or the other way around, lookups. And what BIM does is actually give everything, all the data, a very specific location. Because if there's something these guys, the operational managers, etc., do a lot, it's actually looking for stuff, not only physical stuff, but they're looking for drawings. Where on which drawings can I find this component, this ID? When you have an alarm in the building automation system on an ID, where is this component reflected in a drawing, and where can I physically find it in the facility? And that's actually something BIM can help you solve. If not everything goes dark. And then you try to disconnect it, and you connect it again, and you hope things will sort out. And it did when I tried it in the break, but it doesn't now. So, but it's really looking fantastic from here. There you go. Okay, so this guy here taped something from his phone. So this is his Galaxy S7, where he's navigating the files. So this application here is streaming the data. But what he can connect to from the IFC file, thanks to his efforts with the rebar, is actually able to find IDs in the IFC file on basically anything here. So we made a test now converting these old database structures into a more BIM-ified structure of those classifications, adding that to this new terminal. They actually remodeled the entire terminal, so they have quite a lot of, it's a huge data set. I think it's 16 gigabytes of IFC files. So you need something capable of actually presenting that in the viewer. I don't know if you can see that, but this is the interface of a phone. It means that the information is available for the guys on site. And they invested 120 million pounds or something just in the design, and now the maintenance and operations guys, they want some return of that investment. So they've been looking on models for years and asking when can we get our hands on it. Now they can, actually. So next time they have, or let's say in a few months' time, when they have alarm going off in the building automation system, they got an ID, they can just ask the model, where is this component? What does it belong to? Which kind of system is it? Which product has been used, etc. It's all connected now. Yeah, so I guess we're over time and then some. So thanks.
Thanks.
Thank you. Thank you very much, gentlemen. I'm not going to ask for questions because you're joining us for dinner as well, aren't you, this evening? Yeah? So,
I thought so, but
oh, you're not? You are. So if any questions for these chaps, then ask them over dinner because we need to clear. Hang on. Evan's got one? Microphone. Sorry, Miguel.
Your data will be quite critical for you. Can you explain a little bit where is that data stored? Do you control it or is it somewhere in the cloud?
It's not in the cloud. Our strategy, or Avinor's strategy, is to hold the data sets themselves. The BIM server from Jotne is on a local server, so is all the native files. And that's the strategy for, as we know, per today.
But there is a copy in the cloud.
Small one.